This is the QR code for the survey. I'll have another slide at the end. Your feedback is appreciated. Also, you can win some prizes. This deck will be on my GitHub repo at the end, later tonight. If I don't have time to answer any questions, please feel free to reach out on Twitter or X, whatever they call it these days, and LinkedIn. A little bit about myself. I've been working with data and analytics for the last over 20 years. I started as a Java developer, though. But didn't last long, was just a year. After a year working as a Java developer, I started writing queries on SQL Server 6.5. I just aged myself here. And after that, wrote a lot of queries and for reports, and also data warehouses, data marts. Transitioned to the first generation data lake, build the on-premise data lake with Hadoop. Don't miss that at all. And then start working on the cloud, lake houses. And with that work, it came a lot of automation, to automate code, to deploy to the cloud, to lake houses, a lot of Databricks. And since our primary users for the lake houses were data scientists, I started helping them out with automation for their machine learning models. And that's what we're going to talk today, the lessons learned, the whole process that I went through when I started helping them out a few years ago. So we're going to start at the high level. What is MLOps? Why we need it? Real quick intro. Then we are going to talk a little bit about the machine learning lifecycle and how MLOps fits into this lifecycle. Then we're going to dive into the data and model management. We are going to talk a little bit about deployment strategy. Then we're going to close this session with monitoring and serving. By serving, I mean how do we expose your model for the consumers to consume the output of that model, even if the consumers is another application, or business users, or a Power BI report, whatever it is. So let's get started. What is MLOps? So MLOps is a process. It is not only deployment, right? Usually, say MLOps. Of course, deployment is the main component of an MLOps stack, but it is more than that. It is also monitoring and scaling your process to support an end-to-end life cycle of your model. DevOps has been around for several years. MLOps is an evolution of that, right? We added data ops and machine learning ops on top of it. Now, why do we need MLOps? I'm pretty sure everyone has seen this diagram here before. This is from a paper from Google from 2015, almost 10 years old, but it never been so relevant because it talks about the hidden technical debt in machine learning systems. If you can see here, like the machine learning code is a small portion of a big solution, right? That is enabled by, or that has machine learning or AI. There are several other components that we need to include or that we need to address as part of the end-to-end machine learning system, such as monitoring, an automated process to collect the data, and also feature extraction, right? Some automation around everything around automation for everything around the machine learning code. So that's one of the reasons, according to Gartner, why only 50% of the projects make it to production, right? Only 53% of projects goes from prototype or development all the way to production. And the main reason is for the lack of a production-grade AI pipeline or an end-to-end pipeline for the models to be deployed. There are many other challenges that MLOps solves. Due to the time, I'm just gonna touch on a few of those here. Lack of governance, right? Without an MLOps process that I can apply data reproducibility and model reproducibility, I might not meet my governance guidelines and my compliance guidelines. Also, to catch errors before they hit production, right? I remember way back when, several years ago, some data scientists on the team, they were writing or logging the results of their model in a shared Excel spreadsheet. And sure enough, there was a typo, and one of those models, the wrong model, made it to a higher environment. There was no automated process for that. And also drift, right? That's a very overlooked component of the ML stack, which is monitoring for drift. And when I say drift, it's not only the model drift, right? It's also the data drift. We're going to touch a little bit on that on the upcoming slides. So now that we kind of review why, what is MLOps and why we need it, let's spend a couple minutes talking about the ML lifecycle, right? So the middle portion here of this diagram, that's the development, right? We've been doing this for years, where we plan, we gather requirements, then we create our software, we test, we package it up, and then here on the ops side, we release to a target environment, we monitor. With the machine learning, we added one more component to the front of it, which is the work of the data scientist. That's everything that the data science do, or the data science team, but everything they do, which could be from exploratory data analysis to working with the business to ideate about the problem and start building some models to make sure that can be solved. I really like, this is another representation of the same diagram. This is from ml-ops.org. They have a lot of diagrams and processes around MLOps. I really like that one because start dissecting each one of those processes, right? So the design is the data science portion. Model development, that's when we are productionalizing whatever the data scientists did during the design phase. Start productionalizing during the model development. Then operations, which is the automation of that model, the deployment of the model, and monitoring of the model. So if we break it down this one level deeper, here you have a more detailed view of all the iterations of the machine learning lifecycle, right? As I mentioned, the yellow part or orange part, that's the data science work, that's exploratory data analysis. In the middle here, we have the blue iteration, right? That's the development. We have some data engineering there, depending on the size of the project, depending on the size of the data. We might need a data engineering team to automate the data ingestion. And then finally, in green here, we have the iteration to not only deploy the model, but also monitor the model and identify any drifts. So that's the life cycle. If we throw our ML stack on top of this life cycle, we have something like this here, a very busy diagram. So there are 10 items here, and that's where we are going to review over the next 30 minutes or so. Those are the functional requirements for your MLOps stack. There are many tools out there that are AI enabled and can help us to accomplish some of that. For the purpose of this demo, we're going to focus on Databricks, but we could do this in Azure ML or on any other, or use multiple tools for that. So in Databricks, we're going to walk through all of those 10 steps and how to take advantage of Databricks to implement an end-to-end MLOps process. So let's start with, so the value proposition, I just added here because that's very important. We're not going to track that in Databricks, but I have a little demo here, some notebooks that I'm working with some data. And the data is based on Airbnb listings. So there's a bunch of, it's a sample data set from Databricks. If you have Databricks, it's available under the sample data set. Very simple. We're not going to focus on the model. We're just going to focus during the process during this session. And the goal is to predict the prices of listing on Airbnb, right? So this data set has 90 columns, 90 features. Just gonna use them to say, like, for this house here with these characteristics, with these features, should be renting for X amount of dollars or pounds. So let's move on to Delta Lake. Let's talk a little bit about Delta Lake. And the way we're going to use Delta Lake in our ML stack is for data versioning and data reproducibility. So if you're not familiar with Delta Lake is an open source project. It was created by Databricks. Databricks made it open source. And it is the default on most lake houses. It's the default on Databricks. It's the default on Synapse, Fabric. Everybody, or almost everybody, uses Delta Lake. It brings ACID compliant to object store, and it is scalable. There are many, many, many features in Delta Lake. Version 2 was the version that was made open source. However, last year, they released version 3. But the features that we're interested for our ML stack is time travel and audit history. So the reason why we are interested in those two features is because reproducing the same environment and conditions that a model was created is essential, right? For compliance reasons, especially if you are on the financial industry, insurance, government, right? So the way we leverage Delta Lake for that is a Delta Lake table, it keeps the history, keeps the versions of the table. What that means is if I drop a column, or if I insert new data, if I update the data, it will create a new version of that table. And I can access this version by using a timestamp as of a specific date, or getting the specific version of that table. So let's jump to Databricks. I'm going to show you real quick how that works. I have this notebook here. And again, just going back to that diagram, this is addressing the data reproducibility, right? That if I train a model, can I retrain this model with the same data, or use a different algorithm on the same data to compare the results? So over here, I have this notebook. I'm just using the San Francisco listings for Airbnb. Real simple example, I'm creating a data frame over here, right? I'm reading the data. Creating a data frame up here from the CSV file. And here I am writing, or I'm creating a Delta table. Then what I'm going to do is I'm going to drop the column here. I'm dropping two columns, cancellation policy and instant bookable column. I'm going to drop those two columns. Now, if I go to, and I'm going to write this data frame. I'm going to overwrite this data frame to the same table. Now, if I do a describe history on that same Delta table, you see here that I have two versions. Version 0, which is the original one, and version 1, which is the version that I overwrote without the two columns. Well, now if I want to access the original version of that same table, I can come over here and just create a new data frame, spark.read, format is Delta, and the option version as of 0. So at this point, I'm using the original version of that table. So that will help me on keeping a version of the data that I can retrain, or that I can train different algorithms, different models using exactly the same data, right? Even if the data is changing, I don't need to worry about that as long as nobody run a vacuum on that table, as long as nobody deletes the history of that table. And it is audited as well, right? So I have out the log here, everything that happened. So this I executed this a few hours ago. So we have here all the operations, everything that happens on this table is out logged. So that meets the requirement on our ML stack for auditing, right, or compliance. I can have a full stack of that. So next, let's talk about the feature store. And so a feature is a fancy way to describe a column, right? So a feature are the elements or columns that is used as an input to a model. Sometimes we need to do some transformation, right? For example, what we have here on the screen. We have this work class column, and I want to create individual columns for them. Of course, that's a very simple example of a transformation. There are many other types of features, many other examples of transformations. The most important one here is the pre-computed features, right? When I want to create a feature that I want to feed to my model, for example, number of purchases over the last 7 days. But the challenge becomes when I have a big team. So in this scenario here, I have the full life cycle, if you will, right? I have the raw data all the way on the right side. My developers or data scientists or data engineers, they are doing some type of transformation. Then they use that data to train the model. Then that model is served to some type of client. Could be a report, an application. Well, the challenge becomes when we have a big team, or even if it's a small team, right? But if you're working on the same data set, transforming a lot of the same data, there's a lot of duplicated work, if you will. I'll give you one example. I used to work for Disney, and at that time, I think now it's even more, but at that time, they used to have more than 100 data scientists on their team, right? It was a shared service that anyone needed any type of advanced analytics project would come to this team, and they would do the project. Well, there's one very common data set for Disney, right? That's not a secret for anyone. The Bob Iger, which is the CIO, the CEO, they talk on earnings calls all the time, which is the customer, right? Which they don't call customer, they call the guest. They use that data for everything to personalize, the guest stays, their offerings, like everything is guest-centric. So that is a very common data set that all the data scientists were using to do transformations. And there was a lot of duplicated work. So the way we solved this was implementing a feature store. So if you are building this feature around the guests, let's just do that once, transform that once, and put on a feature store. So Databricks has this feature store. It's two components, right? You have the feature registry. Imagine like of a table, right, or a central repository for your features that you register, and then anyone developing the models can consume from that table. The feature registry, that's based on Delta Lake, so it also keeps the history of all the features. And then we have the feature provider, which is based on MLflow. So let's take a look here in the UI. How does that look and what problems does that solve for us? So on the same notebook here, I have this piece of code, the feature store. So as I mentioned, it's a centralized repository for features. And the only thing I have to do is very simple, right? I'm gonna reuse that same data frame that I created. And the only thing I have to do is to import the feature store library. And I'm going to do an fs.create table. I pass the table name, what fields I want to use as a primary key, what data frame I am creating this table on, and I create this feature. Now, if I come over here under the Features tab, I have my feature created. It will keep history. Anyone using this feature store can come over here and see all the fields that I have, and it can be reused. So I have all of the details here of not only who created, but who last modified, and it keeps track for auditing as well. Right? So that's feature store. So far, we talk about the data management, right? We talk about how do we keep track of different versions of the data for data reproducibility, and how do we create this central repository for our features. Now, let's move along and start talking about model management. So on the model management side, the first item that I would like to touch base here is on for tracking. Because over the course of the machine learning lifecycle, a data scientist will test many, many different models with different parameters, or hyperparameters, I should say. Well, that's where MLflow comes into play, right? So MLflow is an open source platform or framework, if you will, for machine learning lifecycle. It is used to operationalize the machine learning development. It was developed by Databricks. It is open source as well. And by default, if you create a Databricks ML cluster, MLflow is installed by default. So you don't need to install any libraries on the cluster. One very quick way to get started on MLflow, if you haven't yet, is just to use the mlflow.autolog. It will keep track of most of the information when you run your model. So let's jump here to Databricks just to see how that works. I have a quick notebook here, which, again, I'm using that same data set. And over here, I have a function, right, that I'm wrapping using MLflow. Let me just highlight here, MLflow dot. There we go. So I'm importing the MLflow, and I'm using just a random random forest regressor, right? Is a random forest algorithm, and just to predict the price for the listings based on the characteristics of my data set. And if you notice here, I'm logging the model. I'm logging the metric that I'm logging is the mean square error. And when I run this here, it will show me a message here that logged one run on to one experiment. Now, if I go here to the experiment, that's the experiment that I run. So this notebook here, let me go back here real quick. So this is one run, right? It's the basic random forest run on this function here. Then I change some parameters, and I run it again, right? And then I change some more parameters here in the bottom, and I run for the third time, right? So what happened is, when I come over here to experiments, I can see the log of all of those of the experiment, right? But also all of the runs for that model. So here's what I mean by that. So I run the basic run. If you remember, I was just logging one metric. I was just logging the mean square error. However, when I run again, the third run, I'm logging more information, right, or more error metrics, if you will, for that model. And I have a full traceability here, so I can see what was the source notebook. This is pretty cool because from this here, I can go to the original notebook that I ran during that experiment, right? And it will show here right off the bat, you're seeing a past version, right? And it kind of compares with the current version, but that's the version that was run to generate that model. Also, for each of the models that I created here, let me go back here and go to the third run. So I have the model metrics. Of course, there's not a whole lot here. It's just a quick example just to show the features of MLflow. But I have all the artifacts here, right? And including, have an option here to export also the feature importance. So I have how each feature impacts my model, right? That helps me also with model explainability, right? If somebody comes to me, it's like, well, why is this model making those predictions? I can go back and say like, well, those are the fields that has higher importance, and I can start troubleshooting that or explaining that. Also, if I go back to experiment, I can compare the results of each run, right? Of course, the very first here, the mean square error, right? The mean square error I have for all of the runs, but for my first runs, I don't have the R square and the other metrics. So that's experiments, right? How experiments can enable us to keep track of all of the executions of the models, right? I can try different models, and everything is going to be logged here for me. I don't have to keep track of this information manually. I can let MLflow do the work for me. Now, moving along, let's talk about model registry, right? As I train those models, I might want to register the models that could be a candidate for deployment. If I have a model that I'm not interested in, or if the performance is really bad, I don't need to worry about. But some models are like, okay, this model, error rate is acceptable, I'm going to register. And model register is a central repository for your models, as the name says, right? Let's go back here to Databricks. And for example, if we go here to the second run, right, you'll see that I have this option here to register this model. I can come over here and I can create a new model. Let's call this model SQL bits. I can register. All of a sudden, this model register show up here. Now if I go to models, I should be able to see SQL bits here. And I just have one version. Right? Now I can go back to my experiment, and I can also deploy. Let me go back to my experiment. I can also deploy, or not deploy, sorry. I can also register model 3, or the third run, I should say. I'm going to register to the same location and create a second version. Now I have two versions, right? One version for the second run, and another version for the third run. Now, when I register the models, I can come over here and have a list of all the model registers, or of all the versions, right? Going back to that example way back in the day. So it was painful it was a small team of data scientists, was only 3 data scientists, but they have a shared spreadsheet where they were sharing, the metrics of all the models. So this solves that problem, right? Now, let's talk about deployment, right? So we came a long way, right? We talk about the data management side, how to log our experiments, register our models. Now, when we talk about deployment of models, we have 2 assets that we need to consider, right? One is the code, which in the Databricks side are the notebooks. The other one is the actual model, or the model artifacts. And we need to deploy that to development, staging, and production. Of course, some organizations, they have 4 environments. For example, dev, staging, testing, and productions. I have worked with organizations that have 5 environments. They have dev, staging, testing, performance, and production. So it really depends from organization to organization. But there are 3 deployment patterns that are most used out there. And that's based on, if you guys are interested, there is this very good resource from Databricks. It's called the Big Book of MLOps. It is public available. I took a lot of some bullet points from that book for this presentation, and it is on the reference here for this presentation. But those 3 patterns, revolves around the 2 artifacts, right? Models or code. The first pattern is I just deploy the training code, the notebooks, right? As I go from dev to staging, I test my code in dev, generate the model, train, deploy my code to staging. I do the same thing, train the model, deploy the code to production, retrain the model in production, and the consumers can call that model or can call that API. Now, the second pattern is around deploying only the model, right? I train my model in development. Then after that, I just deploy my model to higher environments. Just train once and just deploy the model. And then I have a hybrid approach that consists around training the model in development and staging, and then just deploying the model in production. So for this demo, we are going to use the approach here in the middle, right? That we're just deploying the model between environments. However, the recommended approach that we're going to talk about in a little bit is to deploy the model to deploy the code to all the environments. The reason for that is because of, first, data privacy, you might not have all your data in development, right? Or the data might not have all the fields that you need to train your model in development. And volume, right? For example, I was working with a utility company, and they had a lot of AMI data, right? The meter data that comes from IoT devices, from the IoT meters. And the volume of data was very big for them to keep in development. So what they had to do was to train the model in production, because only production had the entire data set. So it's very common. That's why the first approach is the recommended one. But for the purpose of this demo, I just would like to show the features that Databricks has for this type of deployment. And it's very simple. So you notice here that, going back to the same screen, you notice here that I have the versions of the model, right? So if I go to the first version, I can transition this version here to the model, for example, to staging, right? Of course, I can send to somebody, for somebody to approve, or I can just transition directly to staging, right? And then if I go back to version 2, right, it's like, oh, now version 2 is the good one, the one that I want to use, or sorry, the one that I want to test. I can transition that one. And what happened is, now that version 2 went to staging, version 1 went straight to archive. So there's 3 stages, right? You move from none when you first train the model. You can move from none to staging, and then from staging, let's say everybody's happy with version 2, I can come over here and go from staging to production, right? Of course, somebody would have to approve it. We're just kind of walking through the functionality here, but you can add approvals. But now version 2 is in production, right? So it's just a tag. Being honest with you guys and gals, for everyone, I never use this feature, for a client. Usually, enterprises, they require something more robust, more automated. Of course, you can do that via code. On my repo, you'll see that there is a notebook here, which is this number 4 here, that not only register the model, but also, if you go here to the end, it will also transition the version of the model to different stages, right? So you can do that programmatically, but the recommended approach is to deploy the code, right? And as I mentioned before, right, we deploy the code, we train, we test it, move to the next environment, we train the model, we test it, and then finally it makes to production, right? And as we move forward, not move forward, but as we have more or higher, that's the word I was looking for, sorry. As we have higher production requirements for our deployment, you see that complexity increases, right? So in order to deploy the code, right, to higher environments, and usually, most organizations, they have different Databricks workspaces. When I say different Databricks workspaces, they have one Databricks workspace for development, another one for staging, and another one for production, right? It's not all on the same Databricks workspace. So usually we create CI/CD pipelines or DevOps pipelines to deploy the code. And depending on your production requirements, you might even need to do some A/B testing or some performance optimizations. It really depends on what your organization requires as far as governance and automation goes. But for CI/CD pipelines, right, here we're talking about code repository and deployment automation. So as I mentioned, right, you have 3 Databricks workspaces, one for development, one for staging, one for production. You have the code repository that is getting the latest code from development and using that code to deploy to staging and then pushing that to production. But that's all based on DevOps build pipelines. So those pipelines, you can have manual triggers or automated triggers. What I mean by that is if you, instead of before anything is deployed to staging, especially production, You might have someone to approve that deployment, right? That's a very common practice. But that's how you handle most of the scenarios. That's how you handle scenarios, deployment scenarios on, I'll not even say big organizations, on mid, and of course, big organizations, because you're gonna have a segmentation of your Databricks, workspaces. Now, let's talk about model serving. So model serving is Databricks service that provides a unified interface to deploy, govern, and query the models. Each model that you deploy, you can create a REST API, and has high availability, low latency, and it can automatically scale up or down. It is very simple. It's a click of a button, and I can show you guys how that works real quick. So if we go back to Databricks, let me just refresh this page here. We should have the models that we just registered. And what I can do is, I can go, for example, to model version 2 here, and I can click here, use model for inference. I have a few options here. I can make this model available. I can create an API for this model to be consumed real time. Just think about, a solution that would, or a consumer that would call this API, real time, have the predictions real time, or it can be a batch process where I just send this batch of data, does runs the model on this data, and dumps the results to this location that I have down here. Or I can come to the serving portion here. Right? They do the same thing. It's just here I have some large language models here that Databricks makes available if I want to use. It's out of the box. But I can also create my serving endpoint from this section. So I can add a name here. As I'm typing the name here, if it gives me the URL. Then I can select the model. I can select the version that I want to deploy, and then I can pick the size of the compute that I want this API to use. Right? In this case, I'm gonna stick with CPU, small, and scale to 0. So if nobody's using, it's going to shut that down for me. So when I hit create, it's going to create that endpoint for me. And then I can use this URL here to pass my features or to pass my parameters and get the outcome back, get the predictions back. Then, of course, like anything, in Databricks, I can set the permissions, right? I can set who can manage, who can see this endpoint. So everything that I've been that I covered here, the model registry, the experiment, there are permissions for each one of those resources, right? We can set different permissions for different teams, only to see what they need as far as the development goes. So monitoring. That's a very important feature that we need to have as part of our ML stack that sometimes is overlooked. And this is a session by itself, right? We can have a session, we can have like a workshop just to talk about different techniques to implement monitoring for models. But when we implement monitoring, when we talk about monitoring, it's not monitoring only for the model, but also for the data, for data drift. I'll tell you a quick example. In 2022, I was working on this project with this utility company for what's called smart energy to automate the water heater in the houses, the AC, the heater, right? It was just to optimize all those assets in the house. And the model was trained, was doing very well because it learned the routine of the residents of that house. So what that means is if I was leaving my house at 7 a.m., right, it would optimize the water heater. It would turn off the, the AC because there was nobody home, right? And then based on my habits, I'm coming back home around 5. It would get the house cool for me. And COVID happened in 2022. So everybody was working from home. So we didn't have a monitoring in place. So, and we didn't have automation. So we found that out the hard way, right, after the fact, right? It's like, well, why everybody's going to the thermostat and overriding, the temperature? Everybody is, what's going on? It's like, well, everybody's working from home now. So we didn't have, if we had a monitoring, in place, we could have detected that. We could have detected, it's like, oh, my data changed, right? Doug, Leo, he's at home, right? So we had to retrain the model with a new schedule, if you will, for the resident. So that's just a quick example of drifts. We can start very small, like for example, just building a dashboard, something very simple, in Databricks, using Databricks SQL. Dashboard, just identifying the drift trends of the data. Or we can get something very complex, build something very complex like this here, which monitors the drift of the data, the drift of the model. It is on the reference on the deck. It is a architecture by Databricks that every time you call the model for inference, it will compare the accuracy with the baseline to make sure that the data and the model, they're not drifting. So, with that key takeaways, I would like to leave some time for questions. We covered a lot today, right? We started at a very high level with what is MLOps, why do we need it? Then we start talking about data management. We talk about why we leverage Delta, Lake, and time travel and feature store to manage my data, different versions of my data. Then we jump into model management, talk about experiment tracking, model registry. Then we close with the need, right, to safeguard against drift in model performance, talk about monitoring, and the deployment, right? And the reason why we didn't focus on the deployment because every single MLOps session, or most of the ML sessions, I should say, focus a lot on the deployment, but I purposely would like to focus on everything else besides the deployment. But of course, we did talk about deployment. There's some basic functionality in Databricks that we can use. However, I haven't used that for any of the clients that I work with, at CGI. Most of the automation that I do for machine learning deployment is based on CI/CD pipelines. That's either using Azure DevOps or GitHub Actions. So here's the reference that I've been talking about during the session. This is on the deck. There is a lot of good materials here, a lot of good blogs from Databricks that has the actual code for you to implement and has the steps for you to implement, even if it is this one here is really good about the CI/CD pipelines. It gives you the YAML file for you to implement the pipeline for automation and then deploy across Databricks workspaces, right? Which is very common. I haven't worked with a company that only has one Databricks workspace, right? There's always, most of the companies that I work with as a consultant, they have a development workspace, a UA or staging workspace, and then a production workspace. Right? So with that, just like to leave some time for questions. And also before the questions, your feedback is appreciated. Also, there's some prizes that you guys can win. Hope you guys win some prizes. Any questions? Yes. That's a great question. So the question was where do I spend most of my time, right? As I work on this end-to-end process, where I spend most of my time, and um, I would say most of the time for me, because the role that I usually work is more of a machine learning engineer. So I don't actually develop the model. I just help the data scientists to promote this model to higher environments and do the monitoring. So in my case, it is on the pipelines, on the DevOps pipelines, is on the build pipeline and on the release pipeline, right? Just a lot of YAML files. That's how I spend most of the time. I'm sorry, can you repeat that? I would say the first one is, but after you develop the first one, the first CI/CD pipeline, you can reuse a lot of that, right? So I remember my very first project that I had to develop a CI/CD pipeline. I spent more time than I'm proud to admit here on this stage, but after that, I learned a lot, right? And I could reuse a lot of code. So yeah, the first one, there is a learning curve there, especially, I mean, for me. But after that, I could reuse a lot of code and became simpler. Yes?
In terms of inputting back into these models, would it be possible for someone to input into like Power BI? I'm just thinking like from a business user who doesn't know Databricks, how could they use these models in a sort of user-friendly way?
Absolutely, absolutely. So let me go back a couple slides here. Let me go back to the slide that I'm looking for. Actually, let me do this here. Let me go back. Let me go to Databricks here real quick. It will be easier. Let me just leave here in the QR code in case. So remember when we create this endpoint here, right? This endpoint is for online. I can call this endpoint, online and get my predictions. However, I have an option here of creating, sorry, not here. Let me go to models. I have an option here of creating a batch inference. So what that means is, just imagine that you have the data that you want to predict something, right? So in this case here, you have the data with 92 fields of various characteristics of Airbnb listings, right? The number of bedrooms, the neighborhood, the zip code. So you have a bunch of characteristics, and this will be your input table, right? You're gonna feed that to the model, and the model is going to write the results back to this location here, this output table location. That will be the price of each listing, right? So what you can do is you can put a Power BI report on top of this table here, right? So on this location here, you can create a table, right? You create a table on top of this output location, and then your Power BI report would source the data from this output table location, right? So that's more of a batch inference use case, but that's how Power BI, or even if you just want to run a query, right? So like, oh, okay, I have all this batch data, right? That I want to infer something. You write to a location, then you write a query, or you point your report to that location. Yep. One more minute. I have time for one more quick question. No more questions? Yes.
Could you have, referring to this Power BI, could you have like parameters in Power BI and use this URL link, or do you need to have it in batch?
Parameters on Power BI to
Like,
point to the location?
features as parameters in a Power BI report, and then you could just play around and get the data.
Okay, so the question is if I could use in Power BI, if I could pass parameters to the model, and then have that trained and get the predictions. Did I get the question right? Is that real?
Yeah, or if you have done it, or is it
Yeah, I haven't done that. That's a really good question. I'm thinking here if that would be possible. I need to do some research on that. I haven't done that. I'm not sure.
You
Yes.
you should be able to use the endpoints to just
Yes, yes, using the endpoint, yes.
but not
Yes, you're right.
train, but to use the model.
Yes, using the endpoint, yes. So on the batch, I'm not sure if you can do that, but yes, you're absolutely correct. Yes, good point. Using the endpoint, you should be able to do that. All right, guys, that's all the time I have, or we have. I will be outside if you guys are here, if you guys have any questions. But thanks for your time. I know it's been a long day. I appreciate you guys sticking around, or everyone, sticking around. And I hope everyone have a great rest of your day and enjoy the conference. Thank you.